This video is about integration. Integration allows one to find the area under a curve and is a fundamental mathematical concept. Integration is everywhere. In describing the world and building mathematical models, we often look at what changes and what remains constant. Calculus and thus integration allows us to do that. For example, if we see a car traveling with velocity v, we can calculate the distance it travels by integrating the velocity. The uses of integration extend far beyond this, ranging from analyzing the stock market to describing objects on a cosmological and even subatomic scale. The first major contributions to integration date back to the 1600s when Cavalieri and Fermat described the process using moving points and lines and by breaking up areas respectively. Later, Newton and Leibniz showed that differentiation and integration were opposites of one another through the fundamental theorem of calculus. But how can we really understand the method behind which integration works? Imagine you want to find the volume of a large box and you only have small cubes of 1 meter cube volume. What can you do? By arranging the cubes inside the box, you can calculate its volume using the number of cubes it takes to fill the box. In the same way, we can divide the area under a curve into small rectangles of length y and width a small change in x delta x. The area will be the product of y and delta x, and adding this area we can compute the area under the curve. For n rectangles, we'll have to add n individual areas. Sigma represents the sum from 1 to n. If we magnify our curve, we can see that we'll get an incorrect answer because we leave behind lots of points, represented here in green. We can reduce these errors by using lots of thin rectangles, suggesting that n needs to be large. So, what's the largest number we can do? How about infinity? Taking the limit as n tends to infinity, we can compute our answer. Thus, we can see that we found an expression for a definite integral between 2 points on a curve. Know that when we integrate, we basically sum up lots of areas. Thank you for watching.